Okay, let's unpack this. Today, we're diving deep into something that sounds like it's really pushing the boundaries of science, maybe even, science fiction a bit.
Uh-huh.
We're looking at a specific geophysical technology, one used for searching underground, and then there's this algorithm tied to it.
Right.
An algorithm described in our sources as having, well, surprisingly broad, almost unbelievable predictive capabilities.
That's right. And the sources you've brought for this deep dive, they're fascinatingly diverse. I mean, we've got technical papers laying out electromagnetic physics, geological specifics.
Yeah, the hard science
But
stuff.
then alongside that, presentations, a CV, interview bits that kind of veer into philosophical territory about observation, prediction,
Right.
and listing just a startling range of claimed applications.
Okay, so our mission then is
Yeah.
to navigate these sources. We want to understand what this core technology actually is, how it claims to see deep underground, particularly for resources in places you wouldn't typically think to look.
Right.
And then we absolutely have to explore the truly astonishing range of predictive power that these sources attribute to its central algorithm.
Definitely.
So prepare yourself, because this deep dive, it's going to take us from way beneath your feet, kilometers down, all the way into discussions about quantum mechanics, financial markets, even global events. It's quite a ride.
It really is. So let's begin with the technology itself. The primary geophysical method detailed in these sources, it goes by various names, high-resolution electrical survey-induced polarization.
HRSIP. Yeah.
Often shortened to HREIP. You might also see AFSPIP.
Okay.
But basically, the core concept is electrical exploration of the subsurface.
Okay. And what's it actually trying to measure down there?
Well, it's all about the electrical properties of the rocks and, crucially, the fluids underground. The method specifically measures resistivity, how much the material resists an electric current.
Right.
Polarizability, its ability to store an electrical charge, sort of like tiny capacitors in the rock. And anisotropy, which is whether these electrical properties change depending on the direction the current flows.
Direction matters.
It does. And the crucial point, as the sources explain it, is that these properties, they change significantly depending on what fluids are filling the pore spaces in the rock.
Gotcha. So this method is basically looking for the electrical fingerprint of fluids.
Exactly. So if you have hydrocarbons, like oil and gas, they're insulators, right? They don't conduct electricity well.
Right.
So according to the sources, rocks containing hydrocarbons tend to have higher resistivity compared to rocks saturated with, say, conductive salt water.
Higher resistance means maybe oil. What about polarizability?
Well, hydrocarbons also tend to reduce the rock's ability to store that electrical charge. So the sources say you'll see lower polarizability values where hydrocarbons are present.
Hydrocharge storage. Okay.
And the sources also know a specific electrochemical field anomaly they look for, which apparently appears right at the interface, the contact between oil and water or between solid rock and liquid.
That's a very specific marker they're hunting for. And anisotropy, the directional thing.
Yeah, that relates to how current moves through layered structures. So if you have hydrocarbon-filled layers oriented, say, horizontally, it might be easier for current to flow horizontally along those layers than it is to flow vertically across them.
Makes sense.
And that difference in electrical resistance based on direction, that's the anisotropy they're measuring, specifically anisotropy of specific resistance, as the sources put it.
Got it. So how do they actually generate the fields and take these measurements to detect these subtle differences kilometers down?
They use artificial electromagnetic fields. The sources describe generating these with, large grounded electric lines, sometimes up to 30 kilometers long. Other places mention 10 kilometers.
Big setups.
Oh, yeah. Or using vertical magnetic dipoles. Measurements are typically taken on the ground. But intriguingly, the sources also mention the potential for using satellites or airborne systems.
From the air or space.
Yeah, specifically citing magnetic loops and even, get this, laser beams transmitted from satellites.
Laser beams. From satellites to look underground.
That's what's mentioned, to pick up these low-frequency signals coming from deep underground. They measure specific components of the field, the horizontal electric ones, X and A, and the vertical magnetic component, dBddt, which is just the change in the magnetic field over time.
Wow, laser beams from satellites for underground exploration. That does sound like quite elite. What kind of depth and precision do the sources claim for this tech?
The claims are certainly ambitious. The sources state they can achieve reliable depth penetration up to 7 kilometers.
7 kilometers deep.
Reliably, yeah, and even potentially up to 10 kilometers using additional techniques.
10 kilometers.
And in terms of precision, they claim the ability to identify saltwater or hydrocarbon sources from the surface all the way down to 10 kilometers depth, with an accuracy described as the first meters of thickness.
First meters at 10 kilometers down.
That's the claim. And one source goes even further, claiming the linked algorithm offers 2-meter accuracy specifically on hydrocarbon saturation within a zone.
2 meters accuracy on saturation. 10 kilometers below ground. That's an incredibly precise claim. What's the theoretical basis they offer for this kind of thing?
Well, the sources delve into concepts like vertical versus horizontal skin effect, which helps explain why different EM field components are sensitive to conductivity or resistivity in different directions.
Right, for the anisotropy.
Exactly. And they describe induced polarization, that's the IP part, as the Earth material's capacity for electrical energy storage, which they say is essential for distinguishing different types of fluids down there.
Okay. Is this a brand new technology or has it been around?
According to the sources, this method, or at least a direct precursor, it has a history. They state it's been in use for over 20 years in Russia.
Ah, okay.
Specifically mentioning areas like West Siberia and the Krasnodar region. And they claim a pretty high success rate, a prognosis probability of over 75% using only the electrical exploration data.
Which they say increases to over 93% when it's combined with other geophysical methods.
93%?
Yeah. And they provide a specific example of claimed validation by Ilko Isle back in 2009, where the method allegedly identified a productive zone at 2.7 kilometers depth with over 2 meters of thickness. The current recommended version of the whole package is referred to as HZVP3D.
So they claim a significant track record in validation. What are the other key advantages they list for this approach? Anything else stand out?
There are several mentioned. One big one is that it apparently doesn't require reflective borders underground.
Meaning?
Meaning they could explore monolithic rock formations like granite, which is typically really difficult for traditional seismic methods that rely on boundaries.
Ah, okay. Useful for basement rock then.
Exactly. They also claim spatial determination of deposit contours with 100-meter accuracy. It's also said to operate effectively in all climates with minimal environmental impact. Productivity is described as high, up to 2,000 linear kilometers surveyed per year.
And cost. Did they mention cost? Yeah, the figure mentioned is around $2,500 per linear kilometer.
Okay, so a method with some pretty specific technical claims for seeing underground, finding fluids with high precision. Now let's talk about one of the most, surprising claims in the sources.
Yeah.
Where they propose using this technology.
Right. This is where the geological application takes a really counterintuitive turn. The sources propose searching for hydrocarbons not just in the typical sedimentary rock layers near the surface, the usual spots.
Yeah, sandstone, shale.
But deep within the crystalline basement rock. So ancient igneous and metamorphic formations like granite, places geologists usually consider, not source or reservoir rock.
Basement rock, looking for oil and gas in granite. I mean, that goes against decades of conventional wisdom, doesn't it? Why on earth would they suggest looking there?
Well, according to the sources, the motivation comes from geological similarities to a remarkably successful and admittedly somewhat unique field, the White Tiger Field, Bac Ho in Vietnam.
Ah, yes, White Tiger. That's famous for being, an exception, right? Oil and granite.
It is, and the sources share some pretty striking details about it to make their case. White Tiger is known for its heavy oil production, with potential yields, they say, of over 1,000 tons per day per well from standard wells.
1,000 tons a day per well.
That's the figure mentioned. And they say it has many world analogies, including itself, oddly enough. It was discovered back in 1988 during retesting of wells, and the initial flow rates were apparently incredible, around 2,830 tons per day.
Wow.
And production has reportedly continued at impressive rates, up to 3,000 tons per day for over 35 years. The sources describe it as unique in terms of reserves, with a proven oil column height over 1,600 meters.
1,600 meters of oil column in granite.
And an estimated oil-saturated granite volume of 88.2 billion cubic meters. Based on this analysis, one source specifically recommends drilling to the maximum possible depth in basement rock in prospective areas.
Those are just staggering figures for a field in granite. So what specific geological characteristics of White Tiger do the sources say they look for in other potential areas? What's the checklist?
They highlight things like local uplifts of the basement rock itself, the presence of deep faults, which could act as, migration pathways for the oil.
Okay.
Thermal anomalies, often attributed to uplifted, heated material from deep below, and abnormally low gravity values, which they also link to this crystalline basement uplift.
And the sources explicitly connect this highly unconventional exploration idea.
Yeah, directly to energy security.
Wow.
Specifically mentioning Ukraine in the documents we reviewed, they present this potential for discovering and producing large volumes of local hydrocarbons, referencing those potential yields over 1,000 tons per day per well as a vital alternative to importing or needing to store energy from elsewhere.
Okay, so we have a high-precision, deep-seeing geophysical tech proposed for finding oil in really weird places, like ancient granite, based on the White Tiger example. Yeah. That's one extraordinary thread here.
It is.
The other involved the algorithm used with this data.
Precisely. This is where we get to the mathematical observer algorithm, known as RALF1. Now, while it's central to interpreting the geophysical data we just discussed, the sources attribute capabilities to it that go, well, far, far beyond just geological interpretation.
Okay.
It was apparently developed and patented by Vadim Chernov in Russia back in 2011.
So what exactly is RALF1 from a technical standpoint? How do they describe it?
Okay, the sources describe RALF1 as an inversion algorithm and software package. They state its core function is, and this is a quote, to map the compact action of the forces of Lorentz into a compact property of a physical body or space.
Mapping Lorentz force actions. Sounds complex.
It does. It's said to be intended for use where direct physical interaction with measuring devices is difficult. Essentially transforming data related to how physical parameter changes affect Lorentz forces. Now, this description is pretty technical and abstract in the sources themselves. But the core idea, as we understand it from the context, is that it's supposed to be a powerful analytical tool designed to interpret complex physical signals, like those EM fields, and relate them to underlying properties of a system, even when you can't directly measure those properties.
Okay, mapping actions related to Lorentz forces. That sounds rooted in electromagnetism, which fits the exploration method. But then the sources make this massive leap to quantum physics.
This is where the claims become truly, remarkable. The sources declare RALF1 to be, and again I'm quoting here, the key to solving the main problem of quantum physics, the problem of observer.
Whoa, hang on. Solving the observer problem. In quantum mechanics. That's like one of the biggest, most profound mysteries in physics. How on earth do the sources claim this algorithm does that?
They claim, quite astonishingly, that RALF1 demonstrated the reason for the two different results you see in Thomas Young's famous double-slit experiment.
The wave-particle duality thing.
Exactly. The different patterns you get depending on whether you observe which slit a particle goes through or not. According to the sources, RALF1 achieved this breakthrough by replacing the external observer in the experiment with the software code itself.
The software is the observer.
They're essentially claiming the algorithm's process, its logical thinking as they put it, is equivalent to the act of observation that influences quantum outcomes.
Wow. Okay. That is an extraordinary claim. And they say this algorithm has wider predictive capabilities based on this observer principle.
Yes, they state the algorithm can predict upcoming events and even make sudden, seemingly random events appear logical in hindsight. Or perhaps beforehand.
Okay, let's look at the range of applications then that the sources attribute to this algorithm. Starting back with geology again for a sec.
Right, so in geology, as we mentioned, it's used with the electrical exploration data for tasks like fluid saturation appraisal, defining deposit boundaries, ranking structures by how promising they look, optimizing drilling locations.
Standard interpretation stuff. Yeah. Enhanced, maybe.
And the direct search for hydrocarbons based on detection logging, all with that claimed prognosis probability over 75%. They also mention its use for predicting the location of ore and coal deposits.
Okay.
And the sources note it's been used in places like Poland, citing the Antonin 1 field, as well as Iran and Russia. Now, it's worth noting that in one Polish example provided in the sources, the correlation graphs shown for resistivity versus polarizability using this method had very low R-squared values.
R-squared.
R-squared is a statistical measure, basically tells you how well two variables correlate, how much one predicts the other in a linear way. A low R-squared suggests there wasn't a strong linear relationship shown between those two properties in that specific data set they presented.
Okay, so used in geology, claimed high success, but maybe some variable results shown in the provided data. But the claims jump dramatically from there, right?
Oh, they do indeed. They move into fields like financial markets. The sources claim RALF1 can predict cryptocurrency trends. There's even a graph shown in one source as purported evidence.
Crypto trends, okay.
They also claim it can anticipate market peaks, citing a specific example related to Brent WTI oil prices back in April 2019. They link the algorithm's alleged prediction to a drone attack in Saudi Arabia.
Whoa.
And call this a black swan event, something supposedly unpredictable by standard market models that their algorithm supposedly anticipated.
So from underground oil detection to predicting oil futures market movements linked to geopolitical events. What else? Where else do the sources claim it works?
Meteorology is mentioned. They cite a prediction made by the algorithm regarding atmospheric flow deformation, specifically over the San Andreas Fault, claiming it was different from and presumably more accurate than NOAA's standard forecast at the time.
Predicting weather patterns, too.
Yeah.
And medicine.
Yes, though it's touched upon more briefly. It's mentioned in the context of predicting tumor recurrence. The sources reference the work of a Dr. Belinda Parker on immune pathways and personalized therapy, suggesting the algorithm could potentially predict which patients might benefit most from specific treatments by analyzing complex biological data.
Goodness. This is just an incredible breadth of claimed application, and probably the most sensitive claim in the sources.
Yeah, this is the geopolitical or military application. The sources make the, well, quite striking claim that the algorithm can predict the intensity and specific areas of Russian bombings in Ukraine based on statistical information.
Predict bombing intensity and location.
That's the claim. They even cite a letter of thank you, apparently from Ukraine's National Security and Defense Council, purportedly for proposing the use of these algorithms.
Wow. Okay. Just to be absolutely clear for everyone listening, the sources claim this algorithm, initially tied to finding oil deep underground using EM physics, can also predict something as complex, dynamic, and tragically sensitive as conflict intensity and location. How do the sources kind of summarize RALF1's impact on the electrical prospecting method itself? Does it change how that works?
They phrase it interestingly. They say it can either impoverish or enhance the capabilities of electric prospecting. They clarify that it makes interpretation more reliable in situations where it was previously ambiguous, particularly where the underlying physical basis for the anomalies they saw wasn't well understood. So it seems they view the algorithm as pretty essential for extracting reliable meaning from the raw geophysical data.
Okay, let's try and connect these threads because it's quite a journey we've taken here. We have this highly specific geophysical method designed with claimed high precision to find subtle fluid signatures kilometers underground, even in unconventional rock types like granite. Right. And then the algorithm used in that method is presented not just as an interpreter of that geological data, but as this mathematical observer, capable of predicting outcomes across incredibly diverse, complex systems.
Exactly. And for you listening, the takeaway isn't just about some niche method for finding oil, right? It presents a claimed potential framework for data analysis and prediction that, well, if the source's claims held water, it could challenge existing scientific and analytical paradigms across a whole bunch of fields.
Yeah.
The sources propose looking for resources in really unexpected geological settings based on a specific high-stakes analogy like white tiger. And they claim a core algorithm, one apparently designed to interpret complex physical signals like electromagnetic fields, can also predict wildly diverse events from market fluctuations to medical outcomes, even to conflict zones.
That's really the aha moment here, isn't it? Or maybe more accurately, the wait what moment. The sheer leap the sources make from detecting hydrocarbons in ancient granite with meter-level precision using fundamental EM principles to claiming the ability to predict market swings or military actions using what they describe as the same underlying algorithmic principle based on analyzing how changes affect Lorentz forces. I mean, it's profoundly counterintuitive. It's incredibly thought-provoking.
It absolutely suggests a potential underlying connection or predictive power, at least as proposed by the sources, derived from analyzing complex systems via these principles like Lorentz forces. It's a huge claim about a potential new way of viewing and maybe even predicting phenomena across vastly different scales and disciplines, all stemming from a technology originally developed just to look deep underground.
It certainly leaves you with a lot to consider, doesn't it? We've traveled from the deep earth, searching for oil in granite, to the very edge of quantum mechanics, the volatility of financial markets, and the tragic realities of global events. And according to these sources, it's all potentially connected by claims surrounding a single geophysical method and its linked algorithm.
That juxtaposition, exploring for resources hidden deep within the Earth and predicting seemingly unrelated complex events using the same core claimed ideas and algorithm. It's truly remarkable as it's presented in these sources.
Which leaves us, and you, with a final provocative thought to mull over. Could a technology developed with the highly specific aim of finding something hidden deep underground